Here is question number 3 from both the 2025 AP Calculus AB exam and the AP Calculus BC exam. And check out the description below where I provide links to the other 5 questions that were on the 2025 AP Calculus AB exam. So in question number 3, it says a student starts reading a book at time t equals 0 minutes and continues reading for the next 10 minutes, and the rate at which the student reads is modeled by the differentiable function r, where r of t is measured in words per minute, and selected values of r of t are given in the table shown. Part A asks us to approximate r prime of 1 using the average rate of change of r over the interval from 0 to 2. And we need to show the work that leads to this answer. And it does say to indicate units of measure. That means one of the points earned for this part is to include the correct units. So r prime of 1 is approximately equal to, and we are using the average rate of change between these 2 points. So it would be r of 2 minus r of 0 over 2 minus 0. And we can now replace those values with what they are from the table, which is 100 minus 90 over 2 minus 0. You need to show one of these difference quotients to earn the point on the exam, so make sure to show it. And then the correct answer is 5. Now it does say to indicate units of measure. So notice the numerator would be in units of words per minute, and then the denominator would be in units of minutes. So then we have words per minute, or you could say words per minute squared. So make sure to have the correct unit on your answer. In part B, we are asked, must there be a value of c between 0 and 10 such that r of c is equal to 155, and we have to justify our answer. So I notice in this problem we are given r of t and we are asked about a r of c value. So I know right away that this is a problem that asks us to use the intermediate value theorem. In order to use that theorem, we do need to state that condition is met to use that theorem, which is that the function r of t needs to be continuous. Now the problem doesn't say the function is continuous, but because we know that r of t is differentiable, we do know that r of t is continuous, and therefore we can use the intermediate value theorem. So will this function reach 155? And the answer is yes. Notice that the values of r at 0, which is 90, and the value of r at 10, which is 162, does have 155 in between it. So since r of 0 is less than 155 is less than r of 10, and because r is continuous, the intermediate value theorem does guarantee a value c between 0 and 10 such that r of c is equal to 155. In part C, it asks us to use a trapezoidal sum with the 3 subintervals indicated by the data in the table to approximate the value of the integral from 0 to 10 of r of t dt, and we need to show the work that leads to the answer. So the area of one trapezoid, so the formula for the area of a trapezoid is 1/2 height times base 1 plus base 2. This is going to be the formula that I'm going to use for the 3 trapezoids in this table. So here is my work that will lead to my answer. So the integral from 0 to 10 of r of t dt is approximately equal to, and here's the area of all 3 trapezoids. 1/2, because that's in the formula. Height would be the difference between 0 and 2. Base 1 plus base 2 is 90 plus 100. For the next trapezoid, it'd be 1/2 times the difference between 2 and 8 is 6. And then I add 100 plus 150. And then the last trapezoid would be the difference between 8 and 10, or 2. So 1/2 times 2, and then times the sum of 150 plus 162. If I was taking this exam, that is where I would stop. Question number 3, you cannot use a calculator. I do not want to risk losing the point. So leave your answer just like that. But in case you're curious what number it does equal, it's equal to 1,252. But again, I would not do that. I would leave it as the line above. And now part D, a teacher also starts reading at time t equals 0 minutes and continues reading for the next 10 minutes, and the rate at which the teacher reads is modeled by this function w of t that's defined for you. And again, that's also measured in words per minute. Based on the model, how many words has the teacher read by the end of 10 minutes? And we will show the work that leads to the answer. Now, normally we begin a problem like this with how many pages they've read already, but because it's not given to us, I'm going to assume that the number of pages read already is 0. So I would start with 0 and then add on the integral from 0 to 10 of wt dt, because that represents how many words were read between the time of 0 minutes and 10 minutes. And so that would be the integral from 0 to 10, and I'm going to replace w of t with the function that was defined in this problem. And now this one, number 3, you cannot use a calculator. So we would need to find this integral by hand. So we need to integrate. And so the antiderivative of the given function would be negative 1/10 t cubed plus 4t squared plus 100t. And the way that I did it is I used the kind of add 1 and divide method for each of these. And so now I need to evaluate this between 0 and 10. So what that means is now I'm going to take this antiderivative, I'm going to plug in 10, and then I'm going to subtract the antiderivative with 0 plugged in. So you can see this is what I would have here. Again, just like part C, I would stop right here. I would not risk losing the point, because on an FRQ, you don't have to simplify to earn the point. But just in case you're curious what this simplifies to, it does simplify to 1300. So that's it. Question number 3 from the AP Calculus AB exam in 2025. I hope you found that useful, and go ahead and check out the next FRQs from the 2025 exam.